In the last video, we looked at some slope graphs. And the way to find these graphs is we can evaluate the difference quotient at many points, or we can use the limit of the difference quotient to find a formula. But maybe there's an easier way. To explore this topic, go ahead and pause the video and give me your best answers for problems 4, 5, 6, and 7. And then we'll go back and add some margin notes. All right, I went in and filled in some of the answers, and some of them we're going to talk about, and then we're going to add some margin notes. Now, for the first problem that we did, we had the function f of x equals 2. Then we found that the slope was 0, and we can also write that as the derivative f prime of x was equal to 0. If we have a function f of x equals a constant, then the derivative will be 0. In problem 5, we started with the function f of x equals negative 3x plus 2, and we found that the derivative is negative 3. So we had a function of x equals k times x, then the derivative is just going to be k. And we already knew from problem 4 that the derivative of a constant is going to be 0. Next, we plotted the graph of g of x equals x squared, and the derivative was 2x. So if I have f of x equals x to the n, then the derivative will be n times x to the n minus 1. So the 2 came out in front, and then I subtracted 1 from the exponent. Then 6b says that when h of x is x cubed, the derivative is 3x squared. This follows our rule. The 3 came out in front, and then I subtracted 1 from the exponent. Now, using this same procedure, what would the derivative of j of x equal x to the 4th be? Well, the 4 is going to come out front, so j prime of x is going to be 4x, and then I'm going to subtract 1 from the exponent. So that'll be 4x cubed. What about k of x equals x to the 50th? Well, the 50 is going to come out front, so I have k prime of x equals 50 x to the 49th, because I'm going to subtract 1 from that exponent of 50. So what's happening here? Well, the exponent becomes the coefficient. Then the new exponent is 1 less than the original. All right, question 7 says, what do you think the derivative for x squared plus 6 would be? Well, we found the derivative of x squared on the previous page. That's just 2x. And we also found that the derivative of a constant was 0. So the derivative for x squared plus 6 is just going to be 2x. Let's look at 7b. Here's our function j of x. So to find the derivative, j prime of x, I'm just going to take the derivative of each of these little pieces. So the 3 comes out in front and multiplies by negative 19. That's going to get me negative 57. Then the exponent is going to decrease by 1. So 3 minus 1 is going to be 2. The same procedure works for the 4x. The exponent here is really 1. So the 1 comes out in front, multiplies by 4, so that's going to be 4. Then I'm going to subtract 1 from the exponent. X to the 0 is just 1. And then the derivative of negative 3 is 0. So that would be plus 0, but we don't need to write that. I just realized that I like to keep my answers in a different color other than red. So now my margin notes will stick out. So if I have a function j of x equals f of x plus or minus g of x, and I could have a whole bunch more terms on here, then the derivative of that is just going to be the derivative of f of x plus or minus the derivative of g of x. Then the last question says to evaluate the derivative of j at 6. Well, that just becomes plugging in the value of 6 into that derivative function. Negative 57 times 6 squared plus 4. This equals negative 2,048. All right, let's put all these notes together. The derivative d of x of c, or constant, y equals c, this is going to be 0. Then the power rule that we learned says that d dx of our function x to the n, this is going to be n times x all raised to the n minus 1, as long as n does not equal 0. Then the derivative of f of x plus or minus g of x is just going to equal the derivative d dx of f of x plus or minus d dx of g of x. Or we could simply write that as f prime of x plus or minus g prime of x. Then another one we didn't specifically write out is if I have a function with a constant being multiplied by that function. So the derivative of c times f of x. This is going to equal c times the derivative of f of x. Or we can rewrite it as c times the derivative of f of x. If the function is being multiplied by a constant, we could just put that out front, do our derivative, and then multiply by c at the very end. Okay, just a couple of reminders. The square root of x is equal to x all raised to the 1/2. We can't use the power rule when it's in square root form, so we need to convert it to x to the 1/2. The same could actually be applied for any root. If I had the cube root of something, I would need to change that to x to the 1/3. And if I have anything that is a fraction with a variable in the denominator, so in this case maybe just x, but it could be x squared, x cubed, this is rewritten as x to the -1. That should help with some of the practice problems in the next video.